All right, today we've got Ryan Lazarony. Ryan is a cyber consultant with Booz Allen, does cyber operations, cyber defense, cyber fusion, if I remember correctly. Some of the
Yep,
terms
yep.
I've heard you all throw around before. Full disclosure, Ryan and I used to work together back in what I'm now referring to as the good old days. And I'm excited to have you here talk about cyber operations and whatever else is interesting to you. Before we get started, though, can I put you on the spot and ask for your best recent dad joke?
Oh man, that's so funny. I don't know that I have any recent ones, but I can tell some of the ones that you've heard before. Those are my go-tos. Um, so I guess the best one. My whole life I've had this crippling fear of speed bumps, but I'm slowly getting over it.
That's terrible. I love it.
It's awful. Yep.
Yeah, back when we used to work together, we were on a team and we told jokes every day, and you were such a relief because, like, I think I forced everybody to go around the room and tell jokes, and like the first few weeks, nobody wanted to say anything. So, like, your encyclopedic knowledge of terrible jokes saved us, and then, like, a couple weeks in, people started coming up with some pretty good things. I wish I had
Right.
noted some of them down. Those are fun times. Well, cool. Well, Ryan, I know you've got like really deep technical, like incident response um, type experience, and one of the things that I was really hoping to talk to you about is um, how do you figure out what's noise and what's relevant? Just kind of like in general, there's a lot of information coming at you from a lot of different directions. And I imagine, and we hear a lot about that being a huge problem. So let me just throw that out generically. How are you solving for relevancy?
Man, it's that's a huge question actually. Um, I mean, I think it starts kind of up the stack a little bit from actually doing incident response, right? I think it starts with. I mean, maybe this isn't how we start in industry, but how we try to start building this today is with intelligence, right? So threat intelligence is obviously a big key industry buzzword and organization or capability within different cyber teams. But I think where it really starts is just getting information about what is relevant and ingesting that into your organization in some way, right?
Where do you get, like, how do you know what's relevant to you? So I understand it's a big topic. Like, let's start there. Like, you come into an organization, you're a consultant, right? But you work with organizations for a long time to the point where, you can figure out what's relevant to them. How do you, where does that information come from? Like, who decides what's relevant to an organization?
Yeah, that's fair. There are organizations that's all they do. For one, right? They're threat intelligence vendors that do this. There are information sharing and activity centers, or whatever ISAC stands for. There are ISACs across different verticals that do similar stuff in terms of trying to keep their industries informed about likely threat actors and what they should be watching out for. So I think that's the starting point, is that people have made a business out of this, and they're a relatively successful business because they're usually correct about it. This used to just be the domain of government defense organizations. Cyber threat intelligence was only there, and it's been kind of commercialized to a certain extent, and we can leverage that in industry today.
And so you mentioned that the businesses are successful, and then you also said they're usually right. How much of the information that you get from these organizations actually like matriculates into useful, actionable capability?
Yeah, I mean, the answer is that it depends. The everyone's favorite consultant answer, right? Um, so I think high level information is usually very, very good, right? If you are concerned because you're a customer in an oil and gas industry or something, threat intel sources and vendors will be able to tell you which threat actors typically target oil and gas companies. And that information is accurate because it's just historical data. We can see that, you know, these different groups have attacked oil and gas industry companies over the past X number of years. And even tie it back to those threat actors have used specific tactics, techniques, and procedures to attack those companies. So that high-level information is really good. The information that starts to get a little bit hazy and where you just have such a huge volume of data and not all of it is high confidence are the individual IOCs, right? Indicators of compromise. Those IOCs can be IP addresses or domain names or file hashes or whatever else you want, and they are variable in their efficacy when it comes to developing alerts or blocking or even just using it as information during a SOC analyst's response process. But these vendors and threat feeds and ISACs tend to attach confidence ratings to them that'll kind of help you weed out the wheat from the chaff to a certain extent. The reality is that even really high confidence threat intel IOCs that are certain types of data can still just not be useful. Like 100% confidence domain still may not be useful. Certainly won't be useful, you know, a year from now, and probably isn't useful in a week, right? They all have different aging cycles. So we can get into a conversation, I guess, about like the pyramid of pain and like how difficult it is for attackers to change different aspects of their attack infrastructure.
So if I were to play that back, it sounds like probably the most long-lived information is who is coming after you, what are they trying to do, what their motivation, what are the approaches that they're taking to achieve their objectives. And then as you move down, and this kind of follows the pyramid of pain model, right? Like that's the top of the pyramid, the things that are expensive to change. I'll have to put a link into this. I'm going to do a bad job trying to describe what this thing looks like to people who don't know. But then all the way at the bottom are like the things that are easy to change. Like you can change the IP address that you're coming from, you know, in seconds, no problem, especially with all this like generic hosting available. And that kind of tactical information can be useful, I'd say probably particularly in retrospect, like looking backwards, like I knew at this time this person was using this infrastructure, and so I can look backwards to see if I interacted with any of that infrastructure. So that's kind of the value that you're getting from the external parties, like a lot of like framing information and then tactical information that's kind of like a mixed bag of things you can use, things that you can't really use, and whatnot. And there's a short expiry time on the value window there. So that I think to me is like one part of the story, right?
It is.
It's
funny because I took notes. You sent me a little bit about these topics ahead of time, just like very broad. You sent me 3 sentences, right? Of like, I want to talk about this,
I
and this.
didn't, total aside, I didn't, for the first couple of conversations, send anybody anything. I was like, I don't want people to prepare. I don't want people to have these like canned answers. I want them to be like real. Like, what do you think about this?
I totally was prepared.
Like, that's dumb. So this was my first attempt. This is my first attempt to actually send like, hey, these are things that I think would be interesting to talk about.
So I did prepare a little, just a little though. Like basically, almost everything I do is just outline form. Like if you remember back in school where you take like outlines in classes. And so I have notes for like relevance and stuff like that. And really, I have 2 notes under CTI, external and internal. So that's the other part of the story that I came prepared to talk about. Is that where you were going with it?
Yeah, great way to short circuit. Let's talk about internal intelligence.
Yeah.
What is that? What does that even mean?
That's really, yeah. So what it comes down to is that like organizations these days sort of shifting into an intelligence-driven model, and that means they're using this external intelligence to kind of like lay the foundation for their program, but then they're using internal intelligence to continuously improve the program, right? And that can mean a lot of things to a lot of different people, but really it means kind of learning from what you're seeing. So we can see, I mean, and this can be very broad how we define the term intelligence, right? It really is just data that we're using to inform decisions. Um, it can be things from as broad as what kind of incidents did we have in the past? Like, were they mostly malware related? Were they mostly phishing related? And then shoring up defenses based on what you're seeing impacting you. Or it can be a lot more detailed and granular, like we saw 50% of infections over the past year came from a site categorized by our web content filter as benign called legitimatefreedownloads.ru. We should probably block that site even though our vendor doesn't say it's bad. Right? So we can use our own information to further our program. And that can even be extended to using our own sort of like threat landscape, our own environment and asset information to inform how we respond, how we build use cases also. If we know that we're all of our like web app servers that are external facing are vulnerable to Heartbleed still for some reason 10 years later, but we can't fix it, we can't patch it for whatever reason, then we can develop protective technology stacks and alerting analytics that will detect that specific thing, maybe with more rigor than we would otherwise.
Yeah, and just for people who don't remember Heartbleed, it was I don't think quite 10 years, but what we would refer to as a celebrity vulnerability, something that was all over the news, got a clever name and everything. I think the point that you're making is that even old vulnerabilities persist in the wild, and sometimes there's nothing you can do about it. I guess just even more generally than that, like, how do you even know what you need to protect? You know, like, how do you even figure out, like, what's important to an organization to protect?
I mean, now we're talking, like, huge cybersecurity strategy, right? And where do you even start with all of this? And I think there are a couple of models for it.
Yeah, I guess if I was going to put on, like, my analyst hat, right? Like, I'm sitting in the SOC, you know, I'm doing alert monitoring, I'm, you know, responding to things. I've got all this, like, information that's been provided to me, but, like, I'm not a strategist, right? Like, I'm not sitting in these conversations with the CIO and with directors of, you know, different business units. Like, I know what my company does broadly, but like a lot of these organizations do a lot of like weird stuff too that you wouldn't necessarily suspect. Does that information, like, of what's really important and, like, you know, where should shine a light and, like, what they're worried about, like, what could happen, does that information even make it down to, like, the individual level?
Hopefully, but not usually. I guess is the best way to describe it. Right? Ideally, and the way that we would kind of execute against something very complex like, you know, NIST, CSF, the cybersecurity framework, or, you know, looking at risk holistically from an organizational level across the whole company, there are things that organizations should be doing, and in many cases are doing, maybe not as well as they could be, around identifying crown jewels and intellectual property and privacy-related data that they need to secure at all costs, customer data, finance information, that kind of stuff. And that information should be passed down the stack from, policy and governance all the way down to your alerting technologies and making its way on screen in front of your analysts. But that's hard. That's really, really hard. Like CIS, critical security controls top 20 has had asset management, hardware asset management, and software asset management as number 1 and 2 as long as I've been in this business. And those are the two things that organizations struggle with the most. So if you don't even know what all of your assets are, how can you define your crown jewels well and therefore protect them well, right? You can't do these things. And so I think analysts end up being limited in a lot of ways when it comes down to it.
You know what's interesting about that, and this has been a problem forever, right? Like what assets do I have in my environment? Which of them are important? What kind of information are they handling or stored within them? The revolution of cloud was that everybody with a credit card is now an IT administrator. I can sign up for whatever service I want, or I can build my own cloud infrastructure. Now that I have been an administrator of a cloud environment, it's actually kind of difficult to prevent people from doing that. Like if you have AWS or Azure or something like that, by default, everybody in your organization has access to all these things, and you have to go and shut them all off. And if you don't do a good job with that or provide other controls, there's so much shadow IT that can get built. And so I guess the point that I think I'm making is it's hard to do, and it feels to me like it's getting harder. Is that your perception as well?
Absolutely. And we developed technologies as an industry over the past 15, 20 years that would help solve some of these shadow IT problems and help solve some of the asset management problems we've been having. Whether it's, tools that manage software licensing on hosts, like Flexera comes to mind. By the way, I'm not actually affiliated with any of these companies. These are just ones that I've run into. So Flexera comes to mind for managing software licensing, or every vulnerability scanner out there has discovery scans that are available as well, so you can discover hosts on your network. So we kind of started trying to solve some of these shadow IT problems when it came to everything being LAN-based that was kind of under our control. And now we have a totally different environment. It's like we solved shadow IT, and then suddenly shadow IT was able to take place totally out of scope of what we were solving for. So yeah, it's absolutely getting harder.
I a couple days ago heard somebody refer to a legacy technology problem, and then they were like, by the way, endpoints are legacy technology now. And I was like, wow. Okay. I mean, I guess I get what you're saying, right? The coolest revolution in cyber technology, in my opinion, has been the EDR, because it gives you so much more precision and visibility in this two-way relationship to interrogate information or reporting that you're getting. But if the endpoint's becoming legacy, and that's the best tool we have, and organizations are doubling and tripling down on this is the technology that we're going to do a majority of our threat detection on. One, do you see that happening? And two, where does that leave us if the endpoint is in a lot of ways going away?
I think it's true, one, that well, not necessarily that it's legacy, but certainly that it's not the only thing we have to solve for at this point. Really, the advent and adoption of containers and platform as a service and all of these cloud-based functions doesn't play well with EDR as they have been developed today, these EDR solutions. That doesn't mean that we can't solve for the problem in a similar way, because containers still have in some form or fashion, processes that are executing and network connections that are being made, and we can still capture that information, but they certainly aren't architected the same way that systems have been in the past, and endpoints, whether it's end user computers or servers. That's true.
Yeah. As you kind of look around, like what are the other major headwinds or challenges you see coming down the road for cyber operations folks?
I mean, it's really hard to not have cloud staring you in the face, right? Like that is such a huge difference. It's a paradigm shift from how we've done things. Not just virtualization. Virtualization was easy because it was still just endpoints. Just they didn't have specific hardware dedicated to them, right?
And so that, just for everybody's sake, we used to have big server racks in a room somewhere in the office, and those became somebody else's servers somewhere else, and they manage the infrastructure, we run the operating system.
Yeah, for folks who are really in the game now, it's like hosting our own private EC2 instances in Amazon, right? Like we had our own little guest OSs in our own data centers. But that was not a hard problem to solve because virtual networking was still there. It was an OS sitting there that we could still today install an EDR agent on and get the same data from because it was running Windows or some flavor of Nix, or in really weird cases in corporate environments, maybe it was running something Apple. I don't know. But we can't install an EDR agent on a container that exists out there. At least none that I've seen. I'm sure people are working hard on that technology because it would be really useful to capture that. But I think it's not all doom and gloom, right? Because these cloud vendors have come to the table with plans for or implementations of cloud native tooling to get some of the same data. The problem is most of the IR space doesn't know how to use it or what it means or how to be effective with it, even if they do have some basic training, because it's completely new.
Yeah, we've been working a lot with some of those like cloud native detection tools that are doing what you're doing. Like, hey, you can't do this anymore as easily, so we'll do it for you. I think the challenge there is the same challenge that's always existed. It's very easy to detect suspicious actions. They're a dime a dozen. It's very hard to both know which ones are important and then have the information and ability to the ability to gather information or access to the information needed to figure out what happened, where did it come from, where's it going, kind of stuff. That's the part that I think you're talking about, is like the response side. You turn on these detection tools, they'll detect things that I'm sure are interesting, all day long. But as we all know, interesting isn't synonymous with malicious. And just because somebody detects something that is malicious, that's the start of the journey and not the end.
Yeah, I mean that's totally true, and like our structure that we've had forever within a security operations center of tier 1 analysts that follow SOPs to the T, and tier 2 analysts who have some more experience and they can recognize these patterns of bad behavior a little bit more quickly and easily, and tier 3 analysts who are the experts and can also write reports and do threat hunting and all this other stuff. We don't have anywhere near enough tier 2 and tier 3 analysts in industry with these quote unquote legacy systems today, let alone with where we're going with clouds and Kubernetes clusters. It's just totally different. We don't have enough expertise to be really effective in this as an industry globally, right? Um, so what I mentioned patterns specifically, and that's because that's been a differentiator for a really long time between what computers are good at and what people are good at, right? Like computers are terrible at pattern recognition, or at least they were for as long as they've been around until the last 5 or 10 years. Um, if you wanted a computer to tell you if a picture was taken in a national park, that's really easy. It's like geo data lookup. It can tell you, yeah, you were in Yellowstone or whatever. But if you'd wanted a computer to tell you if a picture was of a bird, like good luck. We had to kind of teach computers from the ground up what a line is and what a curved line is and how curved lines and color gradients look like beaks and feathers and wings. Um, and really what we started doing to solve this pattern recognition problem was AI and machine learning. Like there wasn't another way to approach this because we couldn't programmatically assign every possible variable. So between AI and machine learning and like there are older methods that have been used for a long time to great success, like linear regression and prime component analysis that are really cool. But we've developed past the ones that I understand to things that I don't understand anymore mathematically. And it's opened doors for computers to do a lot of the things that previously only people could do, which is really exciting and I guess topically appropriate given Salem.
Oh yeah. We're using some of those new age techniques, if you will. What's interesting though is your comment about mathematically complex. I feel like is probably not true. I think the neural networks, which are like the underpinning of every cool AI thing that have happened recently. Practically speaking, I'm sure somebody will tell me I'm wrong about that in some aspect, but let's just assume I'm right. Like the math in there is very light comparatively to like some of the older techniques that were more analogous to like old school wave analysis and the calculus involved there was pretty heady. That's the kind of stuff I had to learn in school, and I'm glad we've moved on because I can understand this math a lot easier. But yeah, I mean, there's a lot of interesting capability that's we're going to see how it becomes disruptive. One of the things that's really, I picked this up from another podcast. I think it was maybe Lex Friedman's podcast, talking about stable diffusion and DALL-E, the new talk of the town. Those AI engines that like generate pictures. You like start typing and then they like generate a picture based on whatever you ask them to do. And that seems like it would be incredibly difficult, but those types of problems are actually really easy, relatively speaking, to train a machine to do. And the stuff that's relatively easy for us to do, like stand up from a chair, right, is really difficult to teach like a robot how to do that because of all of this like complicated, external factors and, stuff that, I'm not qualified to talk about. But I think some of the things that we think are like the sacred cow that like, a machine's never going to be able to do this, right? Like, I think those are going to be the first dominoes to fall, and the stuff that we take for granted are going to be the things that, we're 20 years away from. So it'll certainly be interesting. I mean, in the time that we've been working on with our AI, we've been very impressed with what we can teach it to do. But the same thing has been true and will always be true. It's more about figuring out how to ask the right questions and get the right information in front of the AI so that it's in a good place to answer the questions that you're asking.
Yeah. I mean, and talking about like learning and neural networks, it's kind of interesting. There was like a YouTuber or something that had been playing with AI a little bit and had done some like farming sim basically. And you know, you kind of set rewards for the AI based on things it gets correct and things it does, like the tasks you want it to accomplish. And it's easy to make mistakes at that point, right? Where, you know, if you give it a point for planting and then it has to wait 10 minutes and then it gets 5 points for harvesting, well, it's just going to plant and harvest right away and just rack up millions of points in that 10 minutes rather than waiting for harvesting, even though that wasn't the goal that you had in mind for it, right? Mm-hmm. So it really comes down to the human input into how we can make this work is the part we still have to put a lot of effort in and a lot of intelligence into.
Yeah. It's so funny when you say it that way, because the only thing I can think of is like the parallel of like human behavior, right? Like what are the incentive structures that exist in the world that get us to do anything? And, you know, we've got, you know,
we don't have time for politics, John.
Well, no, it's okay. I'll get off of it. I just think it's funny. You know, I just think it's funny that you talk about you're rewarding the AI for doing certain things, and then you're like shocked when it like breaks your rules and does something that, which by the way, isn't that the plot to Terminator, right? Like it was given the job of keeping some like people safe, and it realized that like people were the problem, and you know, whatever.
It's like iRobot or all of these sort of things, right? Like the three laws of robotics. I think that's what scares people about AI. You know, the other funny thing that I've observed, especially in cybersecurity, I think it may be less true in other industries. And actually, I'm going to go ahead and assert that it's less true in other industries. Because if you talk about like AI in the context of like Google and Meta and Twitter and TikTok, like people would be like, yeah, that stuff's interesting. It's like taking over our lives. And then if you talk to somebody in cybersecurity and you're like AI, they're like, you're an idiot. You don't know. You don't have anything. It's just like marketing. It's all BS. And it's fascinating because the technology is so powerful, but for some reason, that either the applications to date, the messaging, something is like disconnected in cyber where people are like, no, AI is not any good. Whereas everybody else is like, AI is the future and the best. I mean, and the irony is that, you know, we've been using some form of AI or machine learning or that kind of math, the more complex old forms of math, right? We've been using that to inform what we're doing for quite some time, right? Like any user behavior analytics platform that exists was built on this. Sims that leverage unstructured data and look for anomaly detection. Like anything we ever have done with anomaly detection, that's machine learning. Like you have to baseline and continuously baseline over time and then respond to outliers. And machine learning has been doing that. I think like no one would say that, you know, web application firewall. No one who understands the technology, I guess, would say that web application firewall and its learning mode was a complete waste, right? Because web applications became too complex and too numerous for people to manually tune these things a long time ago. So we had to rely on some sort of automated baselining, and that was machine learning that was doing that. You know, if you use Imperva, whether it's an on-prem or a cloud-based deployment, that's what's protecting your web app. Yeah. So those pieces have been around. I think we just wanted to confine it to a box that we could understand and comprehend within our paradigm of analyst-driven response rather than machine-driven response, and it's hard to get out of that rut a little bit.
Yeah, I think you know, to go back to kind of like the system of rewards, right? Like the anomaly detectors were incentivized to detect different. And I think different is step one on the journey, but that's where the technology ended because that was its like sphere of understanding the set of information that it provided. It could say like these things were different. And then the next step was okay, well, which of these different things is potentially bad, right? Because, the assumption is the attacker objective is always to change something, right? Like just by interacting with the system, they are making a change, something new is happening. If you can detect different, you can detect the attacker. But then the problem space is too large, right? Like there's too many new things that happen and too few of them. I shouldn't say too few, but very few of them are actually, attackers doing bad things. Maybe none of them are doing attackers doing bad things. And so then it's like, well, step 2 was how do you reduce that problem space? And step 2 never came. Now, I didn't intend to get here. That's what we're trying to do. We're trying to be step 2. We're trying to take, that sea and boil it, and collect the things that are interesting. But I think that's probably why people didn't like the technology, because it wasn't like a whole solution. It was like part of a puzzle that was much larger, and without the other pieces in place, like that first piece didn't make any sense. It didn't look like anything, right? Like you can't see the picture yet until the other pieces existed. And I think maybe, and I'm just kind of spitballing here, but like maybe that's why people didn't like it, right? Like it was not ready to go. It was the easy thing to implement. You could push it out the door. Those algorithms look very similar to the types of algorithms that Amazon are using. So you could plug and play them, and nobody took the time to say like, hey, wait a second, like where's the rest of this journey? Because you can't necessarily take like a machine domain, like lots of machine data, lots of machine analytics, and then dump that into a human domain and expect things to go smoothly.
Yeah, I mean, absolutely right. And I think there have been attempts to reduce that scope, that problem set, right? One that comes to mind really quickly is like software whitelisting, right? If we determine every possible good piece of software in our environment, and only allow that, then we've reduced our problem set. We've reduced that scope tremendously. Nothing malicious can ever be installed if we just straight up don't allow it. I mean, vulnerabilities in software whitelisting programs aside, or admin escalations, or whatever workarounds there are, that's still a good idea. The problem is that it's not a feasible goal to whitelist every piece of software in your environment. That doesn't mean it wasn't like on the right path, though, of reducing the problem set. The other really interesting one that comes to mind is, probably back in 2013-ish, a company called Cyvera put together this new advanced malware endpoint agent, and rather than looking for what all of the AV products at the time were looking for, which is just a list of hashes, 2 gigs long that can be changed at the click of a button by an attacker with packing and all these other techniques that attackers use with malware. They said, hey, there are certain things that all malware tries to do. And this was based on research that they did, and they at the time came up with like 9 techniques that always happen, whether it's like a buffer overflow or similar technical activities like that. And then they just said, we're going to block an alert on every one of those, because real programs never do them, like real execution never does it, and malware will always do some combination of these things. Not all of them, but some combination of them. Since then, that list has expanded a whole bunch. Cyvera ended up being purchased by Palo Alto Networks and was kind of like the core for their wildfire, or their endpoint product, not wildfire, traps, pan traps. So Cyvera ended up becoming pan traps. But they were the first ones to the market in this space, and like Cylance kind of followed them and their pattern, and then some of these other next-gen AVs did the same thing. But it was all about reducing the noise and reducing the problem set to something manageable. Now, this was all on the detection side. This is like before it ever gets to an analyst, right? And I think Salem kind of sits in between the two in a really interesting way that I hadn't thought of until you and I had a couple of conversations about it. Um, so I think we're moving in the right direction, I guess, as an industry towards trying to leverage different tools like AI to solve some of these problem sets in a way that people are bad at. Like, because people are great at patterns, we had to teach computers patterns using a lot of this technology, but computers have always been way, way better at just processing data quickly. Way better. And so now they can start to do this with this huge data set and apply some of this pattern recognition that we've enabled them to do and solve the problem in a way that we couldn't on our own.
Yeah. Obviously, I agree with you.
Yeah, I feel like I'm just advertising for Salem now. Like, this is
staking my career on violent agreement with that statement. One other thing, so different but the same, that I really wanted to get an opinion from you on was this idea of what is good enough, right? So, like, we're talking about lots of things that you could do, right? But how do you know if you've done enough? And how do you, like, maybe... Well, let me stop there. I might have a follow-up. Let me stop there. How do you know if you've done enough as, like, a cyber org?
Well, I mean, there's the really cynical and silly statement of, if you don't show up on the front page of the New York Times, then you're doing great. Right? There's that results oriented, and maybe we're talking about the wrong rewards in this case, right? Because if that's your only goal is not showing up in the paper, then there are a lot of ways to do that that have nothing to do with good cybersecurity. So
these days you might just be able to buy the newspaper, right?
There you go. Easy, free speech, sort of. So there are those. Callous sort of descriptions of it, I guess. But the other way is with metrics, and unfortunately, all of this is still kind of dependent on understanding what your success criteria are, and we can follow that all the way back to the issue of asset management, right? Where what's your success criteria if you only understand 50% of your environment? Like, good luck creating good success criteria. But I think if we look at, kind of discounting, we don't know some things, and in a lot of cases we don't know what we don't know, so we have to work with what we have, and we can still develop useful metrics around the success or failure of a cyber program, and there are lots of examples out there, different frameworks for learning metrics and reporting in the industry. But I personally kind of always break up metrics into three groups. Executive reporting, the kind of stuff that will show, like, that we align to executive goals and vision, like we're blocking X number of attacks per month, and we're having this number of incidents, and our response times are going down or up, hopefully not. And as you get more mature and you can quantify risk in a more meaningful way, then you can actually measure risk reduction. Or you can, most businesses, what they care about a lot is how much money is being saved by having this cyber program, right? So I think on the subject of improper rewarding of environments and AI or people, if it was just cheaper to just say, hey, forget it, we're not doing this at all, then people would do that. Like, many businesses would just say, yeah, that's fine. It turns out it's not, thank goodness, so we all have jobs in cybersecurity. But a lot of those reporting metrics are also just the sort of, hey, board of directors, keep funding the cyber program because we're doing the work we need to do. The other metrics that I like to use are sort of external gap analysis metrics and internal gap analysis metrics. And so the external stuff is like, if your containment time is really fast, your analysts are great, they hit that contain button on EDR really fast every time, and they're right all the time, and it's wonderful, but then it takes 2 weeks on average for remediation to occur, then maybe you need to work with your desktop services team and figure out where the hiccup is in that process. So we can ask for help across organizations to try to fix some of these issues that are part of the broader incident response process. And then the internal gap side, I gave kind of like the legit free downloads.ru example earlier. That would be one of those, the introspective sort, or, if containment or initial triage is fast, but containment is slow. Maybe there's a people problem and we need better analyst training. Maybe there's a process problem and we need to establish tighter escalation timelines. If a junior analyst is sitting on something for 30 minutes and they're kind of spinning their wheels, maybe we should have escalated it to a more senior analyst 20 minutes ago. So that kind of process fix, or the technology fix, like implementing a new technology or configuring an existing technology in a different way. So those are my 3 metrics types, I guess, for measuring success in a SOC.
So I guess the question that I have, obviously you're a consultant, right? So like you floated around and you come in your back pocket with rough estimates of like what is good and what is less good. But like if you're just in an organization and you don't have Ryan Lazarony money laying around, like how do you know what good even looks like? Like, are you connecting with peers? Are there like published standards that you can look at? Like, where do you get that info to know, like, is 2 weeks really good or is 2 weeks like awful? Is 30 minutes really good? Is 30 minutes like way too slow?
Yeah, and it's really hard to nail down an answer to any of those questions, right? It's going to vary by organization and industry what these like medians are. You can get, some sort of industry baselines on some of these things. Publications like the Verizon DBIR have good information on like attacker dwell time and what the initial entry point was and root cause analysis. That's all anonymized based on the data they collected from willing industry partners, right? But even that's limited, right? Every company kind of plays with their security incident data close to the vest for a reason. Like, you don't want to expose the weaknesses of your company to the public in a lot of ways. That's disincentivized by our current reward system, right? So I think it's hard to get that information. And so there are self-evaluation pieces that you can do. There are external evaluations that you can leverage, but those all come with some inherent bias, right? I tend to base my criteria for, I want a 10-minute containment time on incidents, or a 20-minute containment time, 10 minutes to triage, 10 minutes to contain. That's based on the most efficient SOC that I've ever worked in when I was in industry. And that's not realistic for a lot of organizations because they don't have the right training, the right processes, the right technologies to enable that. So it ends up being variable, unfortunately. And if there's a good way to standardize it, I would love to know.
Sorry, I was on. Had to put you on mute for a second. I couldn't find the button again. My dog was barking at the mail people again. My dog is very friendly, but the mailman gives him treats, so now he's like, it's caused like the other reaction. It's like, oh my gosh, the treat man is here.
That's funny.
So I guess I'm glad you threw out those numbers. Those are good numbers. Those are pretty aspirational numbers, I would say. I mean, you're saying it's the best place you ever worked. 10 minutes to triage in particular, I think, is the harder one. I think once you know what to do, maybe it's more about like process and tools, right? To actually like hit the contain button to your point. But yeah, I mean, if you can get to 10 minutes, right, that means you're on top of everything. and it means you have access and knowledge of how to get all of the right information right in front of you right away, and it means that you know what that information means, and what are the accelerators, decelerators of a particular situation. That's but it's achievable. There's many organizations out there that have gotten to that point. So
it is. It's not easy. I don't want to give that impression either.
Yeah. I guess maybe last question, and then we can wrap up. What advice or really good resources do you have, or would you recommend for folks who are looking to get better at this?
To get better at SOC and response, that kind of thing. I think sending your people to training is really important. A variety of training. SANS courses are super expensive, but they're also really valuable in my opinion. I learned a lot about how attackers tend to function in environments by going to that kind of training. So leverage that. Leverage, industry peers when it comes to what your goals should be, right? Lots of consultants even will come to you with industry comparisons, like where you stack up against others in your same vertical, and those are useful data points to help you know what you should even be shooting for. So understanding your target is huge. The other piece is, and I mean it's redundant to a certain extent, but asset management is king when it comes to all of this. You can't protect what you don't even know you have. And so invest in that and make that a cultural priority for your organization. So many of these things end up being culture based, and that's a hard thing to fix, right? Momentum is a hard thing to change. If you have a culture of folks just kind of standing up whatever they need to stand up to make the system work, and no documentation and no rigor around what you're doing, that's hard to get back on track. But it is possible. It's not impossible by any means. So having that culture of rigor, I think, helps a lot with laying the foundation for a successful cyber program overall, and that includes the SOC. Most of the challenges that I faced in my time in industry and as a consultant were definitely around the poor foundation that made the actual security team's job hard to do. So I think involving the general IT organization in what you're doing and helping them understand why it's important and how to execute, that's a huge advantage if you can make that happen.
Okay, so knowing what to protect and knowing how to protect it. The sound advice from Ryan.
I mean, maybe that's a little too high level, but yeah.
Oh yeah, so making a little joke there, yeah. But I mean, it's not untrue, right? What you said, go to training, understand what attackers are trying to do, understand the strategies that you can employ, and also the asset piece, right? What do you even have? You hear in the news all the time about online data stores, right, that are open to the internet. And
yep.
I know every time I see one of those, I think to myself, nobody in security knew about that thing. Otherwise, they would clearly say, hey, don't do that. Yep. It just comes down to, well, if you don't know about the thing, it's hard to know, how to keep it safe. So I think it's good advice. Yeah. But the high level, right? Know what to have, know what you have and how to protect it.
I guess the only other piece that I'd add is be willing to change with the times, right? We're shifting paradigms from an IT perspective, and it's important that we change with that as a cybersecurity industry. We need to have solutions for Kubernetes clusters, and we need to have solutions for, exponentially more data that makes it harder for humans to look at patterns. And so those pieces, when it comes to AI and ML and advanced analytics, rather than legacy analytics. Those are going to be critical also.
Yeah, I couldn't agree more. Ryan, I appreciate you joining us today. I appreciate you sharing your knowledge and insights. There's more things on the short list I sent you to talk about than I think we'll have time to today, so we'll have to have you back if you'll have us. But thanks again, and take care.
Yeah, thanks for having me.